This is Geometry Practice Test 3. In number 1, we are asked to classify the triangle by its angles and its sides. So there are 3 possible names for angles. You will either have all of the angles are small, in which case that would be called acute. If one of the angles is 90 degrees, that would be called right. And if one of the angles is bigger than 90 degrees, that would be obtuse. For the side lengths, if all the angles are different, that would be scalene. If 2 of the side lengths match, that would be called isosceles. And if all 3 of them are the same, then that would be called equilateral. In this case, we can see that these 2 side lengths are the same side length, so I'm going to go ahead and indicate that there's 2 side lengths that are the same, and 2 angles that are the same. Therefore, this is an isosceles triangle. It's supposed to be an isosceles triangle, and that qualifies for the side length. You know it's isosceles. But what about these words? All of these angles are less than 90 degrees, therefore it is an acute triangle. So my final answer will be an acute isosceles triangle. And number 2, classify each triangle by its angles and sides. Based on your decision on the actual lengths of the sides, or base your decision on the actual lengths of the sides and measures of the angles. Okay, well, clearly right here, this angle is bigger than 90 degrees. I would say it's about 120-ish degrees. I'll say about. I'll do a little tilde to say about 120 degrees. So it's definitely obtuse for my angle word. And for the side length word, I don't think this length and this length are different lengths. This length is clearly way big. I'm pretty sure this is small, and this is medium, and this is large. They're all different lengths. When I have all different lengths, I wrote up here above, it's scalene. So this is an obtuse scalene triangle. And number 3, sketch an example of the triangle described. Right, obtuse. Well, funnily enough, right and obtuse both describe angles. Right means one of the angles is 90 degrees. If one of the angles is 90 degrees, no matter what I do, no matter how far I draw this line out, there's no way that these 2 angles can ever be more than 90, because 90 plus 90 adds up to 180 degrees, and these will never hit each other. They'll be parallel lines, or this one will come out this direction, or this direction, or this direction, and that will never form a triangle. So this one is impossible, or we're supposed to say not possible. So in the instructions, just reading them, we'll say not possible. All right, and number 4, solve for x. Well, I know that all 3 of these angles are the inside of a triangle. Interior angles of a triangle always sum to 180 degrees. This angle mark up here means we have 90 degrees. So if I add 90 with 50 with that 4x plus 4, all 3 of these angles, that was one of them, right? All 3 of these angles adds up to 180 degrees. So let's go ahead and combine like terms. 90, 50, and 4, that adds up to 144. Don't forget we still have a 4x, and that's equal to 180. I can subtract 144 on both sides. That's going to be 36 is equal to 4x. And then finally, you can divide by 4, and x is equal to 9. In number 5, we're trying to find the measure of angle A. In order to find the measure of angle A, we first need to find x. Once I find x, I'm not done. I plug it back into this expression and find that angle. Again, I know that this angle and this angle and this angle all add up to 180 degrees. So let's say that I have 12x plus 4. That's one of my angles. That's going to add with 76. That's going to add with 15x. All 3 of those angles add up to 180 degrees because a triangle's interior angles always sum to 180. From here, I'm going to combine like terms. I have a 12x and a 15x for a total of a 27x. And I have a 4 and a 76 for a total of 80. And that's going to be set equal to 180. I'm going to subtract 80 on both sides, subtract 80 on both sides. That's going to leave me with 27x is equal to 100. And I feel like I might have made a mistake because I don't think this one comes out very nice. For number 5. What's my mistake here? 15, 27. Ah, I see my mistake now. And if you caught it before I did, then you can log some extra credit. I have a -4 here, and I accidentally wrote down a +4. So let me go ahead and erase that +4. Oops, I could have just gone like that. Make this a 27, or make this a -4. That makes this a 72. So here we go. Let's fix this. 76 minus 4 is 72. And I have to subtract that 72 from both sides, so minus 72. Oops, let's change the color correct. 72 and 72. And that is going to be 108. And I know if I divide both sides by 27, divide both sides by 27, I could use a calculator, but I know that x roughly, if I do 100 divided by 25 is 4. An extra 2 there is going to make that still 4. Okay, yeah, that works out. So x will be 4. And again, I'm not done. I need to plug this x into, and this gets plugged into our x over here. And our final expression is going to be, oops, it's going to be 12 times this x of 4 minus 4. Oops, I'm going to switch colors here. Minus 4. So this is going to be 48 minus 4, which is 44 degrees for my final answer. In number 6, we're trying to find that question mark angle. And you have to use the fact that a triangle has interior angles that sum to 180, which means that this angle, and this angle add up to 180. Let's go ahead and have a temporary variable here called y. I know that 20 plus 55 plus y have to add up to 180 degrees. Therefore, 75 plus y is equal to 180 degrees. If I simply subtract 75 from both sides, I'll get y is equal to 105. So I know that this angle is really equal to 105. And because of vertical angles, this angle down here is 105 as well. And I know that this angle, and this angle add up to 180. So I'm going to go ahead and say that. I have 105 plus 50 plus the question mark. And all of those should add up to 180 degrees. So combining some like terms, I get 155 plus the question mark is equal to 180. If I subtract 155 on both sides, I get question mark is equal to 25. So 25 degrees is my final answer. I'll box that. All right, in number 7. I have this exterior angle right here of 47 and these two interior angles. I know for a fact that these two interior angles adds up to this one exterior angle, and I'm just going to say that. I'm going to say 147 came from adding 87 and the question mark, which means I just simply subtract 87, not 88, but 87 from both sides, and I get question mark here is equal to, well, the 7s cancel out, and then 14 minus 8 is 6, so 60. So question mark is equal to 60 degrees, final answer, and box it. In question number 8, again, I know that the two interior angles that are opposite of this exterior angle, they have to be on the other side, add up to that exterior angle. So I'm going to say that. I'm going to say that 27x plus 5, that is set equal to those two numbers added up, 20x and 40. I should say those terms added up, shouldn't I? From here, we're going to we can't really combine like terms. We have to move an x over. I'm going to move a 20x, move a 20x, and that's going to make those go away, and that's going to leave us with 7x over here. We might as well, if this side has the x's, we don't need this 5. Let's get rid of the 5. Minus 5 and minus 5. That's going to get rid of the 5, and that's going to move it over here. 40 minus 5 is 35. And finally, we just divide both sides by 7, divide by 7, and x is equal to 5. For our final answer, which we will then box. In number 9, we're trying to find the measure of angle R, and again, you're using the fact that these two interior angles add up to that exterior angle. So let's write that down. I have 121 is equal to 23x minus 3. That was one of the angles, right? And then I'm going to add that with another of the angles, which is 7x plus 4. That's the other angle, right? So I'm going to go ahead and combine like terms. 23 and 7x, sorry, 23x plus 7x is a 30x. Minus 3 and plus 4 adds up to a positive 1. And I still have that 121 on the left. Let's go ahead and subtract the 1, giving us 120 is equal to 30x. And finally, divide by 30, divide by 30. and x is equal to 4. Notice that in number 8, I was asked to find x, which I did. In number 9, I'm asked to find the measure of angle r, which I have not done. I found x. What I need to do is plug it back into our x over here to find this angle r. So I'm going to rewrite 7x plus 4, because that is the measure of angle r is equal to that value, and plug in or substitute our 4 that we found up here. So 4 goes right there, plus 4. 7 times 4 is 28, and 28 plus 4 is 32 degrees for our final answer, which we will then box. We're moving on to number 10. In number 10, we're going to complete each congruent statement by naming the corresponding angle or side. Just as a reminder, an angle will either have 1 letter or 3 letters. A side will always have 2 letters, no matter what. We only do 3 letters on an angle if it is unclear which angle we are talking about. Remember that an angle has this symbol, a side has usually like letters A, B with a line above it, and a triangle has a triangle out in front of it. Those are the 3 symbols we typically see in congruency statements. All right, in number 10, it tells me that triangle LMN is equal or congruent to triangle MLY, and it's already done all the tick marks for me. I just need to find the matching line segment with NL. NL is clearly this line right here, which has 3 tick marks. The other line segment that has 3 tick marks is this line over here, and we need to give it in the correct order. N had 3 tick marks, which means our first angle should also have 3 tick marks. Therefore, our first letter will be Y. And it is this line up here, so Y connects to M, so it will be YM. And I have a bar above it because a line segment will always have 2 letters. In number 11, it doesn't give me any diagram. It just tells me triangle UST is congruent to triangle SUJ. So it's saying angle U, and to define U more clearly, they do TUS, is congruent to, well, U is right here. U must be congruent to S. So I'm going to go ahead and put an S in the middle. This is going to be angle. Again, angles can either have 1 letter or in this case 3 letters. I need 3 letters. U is in the center, U is in the center, therefore S is in the center because the first and first. And then it goes T and then S, so T and then S, so J and then U. It'll be J and then U. This says that angle TUS, or angle U, is congruent to angle S, or angle JSU. And you have to have these letters perfect. There is no other answer for number 11. Some people think that you can say angle USJ, if you switch the U and the J, that will dock you half a point, because while you're talking about the exact angle, you have to have the order correct. It goes 3, then 1, then 2, 3, then 1, then 2. All right. In number 12, write a statement that indicates that the triangles in each pair are congruent. All right. We just need to talk about these triangles. So to talk about triangles, we have this symbol for triangle. It's the delta symbol, I suppose. All right. I'm going to do 1, then 2, then 3 to make it as easy as possible. This angle is Y. So it's going to be triangle Y, and then the second one is H, and then G. And that's going to be congruent to, notice I went from 1 to 2 to 3. So over here I'm going to go 1 to 2 to 3 as well. So it's going to go Y, then X, then W. Y, then X, then W. I have made a mistake here on accident. I'm going to move this out to the side. I need to say that this is triangle, those letters. I said these letters, I forgot the triangle, so I need to move this over here as well and say this is congruent to that triangle. There are many different answers for number 12. I could have instead said H, G, Y, and X, W, Y. I didn't have to do this exact order. There are many different answers. All right, in number 13, we are determining if the 2 triangles are congruent, and if so, we state how we know. Notice that these 2 triangles share a side. This side right here is shared with both triangles. So we have, in order, a side, an angle, and a side. This one has a side, angle, and the same side. Because they are the same statement, you can say side, angle, side. So I'll say, yes, they are congruent by side, angle, side. And number 14, let's go ahead and look. It appears that 14, we have angle, side, side. I'm going to write that down, even though it's incorrect. Angle, side, side. This amount of information is typically never enough to determine if triangles are congruent, because it's right only 50% of the time. However, if we have a 90-degree angle, this changes this definition to hypotenuse leg, because it is a 90-degree triangle. This is the hypotenuse, and this is the leg, therefore the name hypotenuse leg, and these are congruent, so we'll say, yes, they are congruent by hypotenuse leg. In number 15, we have leg angle, which can only happen if we have a leg and an angle. With these right triangle theorems, we always ignore the right angle, so we are not allowed to use it. I'm going to go ahead and cross it off here, cross it off here. It does not work. We need to have leg and then an angle. We see the angle here. We see the angle here, which means if I were to try to put this triangle on top of this triangle, the way that I would do this is I would have some sort of line of reflection right here where I would reflect this triangle down onto this triangle, kind of folding it over this blue line so that this angle and this angle match up. So we have an angle, we have an angle, we have this angle, so we can go ahead and put a check mark on the angle. The only thing that we don't know is a leg. The only thing that we need to list is a leg. So I'll just say, sure, let's go ahead and say that this leg and this leg are the same, because if I fold it over this blue line, this leg and this leg should be the same length. They should be congruent. So I can say that CL, that line segment, CL, line segments always have two letters. That line segment is congruent to the other line segment, JL. The order of these matters. If I started with C, then I have to start with J. I could have alternatively said LC and LJ. If I switch this one, I could also switch this one. That is one of the two answers, and you'd only have to give one, but because I am going above and beyond, I want to show you that you can also have this leg. That is another leg. We only need another leg. I have this one, or I could have chosen this one. This one could have been LB. So I could have also said LB. That line segment is congruent to the other line segment. I started from the center and when I went out, that means I have to start from the center and come out. I could say LK in this case. LK, and that needs to be a line segment, so I put a line segment above it. Either one of these would be full points. You do not need both. In number 16, we need an angle, angle, side. Angle, angle, side. So let's check. We have an angle, and then we need a side. In that order. I could have also gone the other way. I could have gone angle, angle, side. I can either say this side is congruent to the other side, or I could have gone this side. Either one works. I'm going to randomly choose that side. I think that's what most students will do. We read from left to right, therefore you'll do angle, angle, and then side, going counterclockwise in this case. Notice that I went from 3 to the 2 and then our side. So I'm going to go from 3 to the 2 and then our side. So these two line segments need to be congruent. So the way that I say that is I say that FH, that line segment is congruent to this other line segment. And notice that I started with the angle with 2 marks. So I'm going to start with the angle with 2 marks, P, and then R. That is one of the two answers. Again, I can flip these and say HF is congruent to RP, those line segments. Or I could have done this. I could have also said this line segment and this line segment are congruent, because that would still be angle, angle, side. And I could say angle, angle, side. So if I do that, you could also say something like this. You could say GH, that line segment is congruent to, okay, I started with 3 angles. So I'm going to start with the 3 angles. Q is going to be QR. QR. Again, for number 16, you can do either one of those to get full points. You do not have to do both. In number 17, we want to solve for x. And it tells me that this angle down here is 5x plus 5. Well, because this is an equilateral triangle, every single one of these are the same. Each one of these angles must be 60 degrees. If this is 60 degrees, this is also 60 degrees, this is also 60 degrees, which means this 5x plus 5 is equal to 60 degrees. That's one of the definitions of an equilateral triangle that we might have brushed over in the notes, but you're definitely learning it now. From here, we're going to subtract 5, and we get 5x is equal to 55. And from there, we are going to divide by 5. I want to do this in a different color, though. we're going to divide by 5, and x is equal to 11. Final answer, box it. For number 18, I know that this angle is 64, and I know that this is an isosceles triangle. If this is an isosceles triangle, these two side lengths are the same, and these two base angles are the same. Therefore, this angle up here is 64. If these two angles are 64, we can figure out this angle right here because we know that these three angles must add up to 180 degrees. I will temporarily call that angle y. I'll say that angle y plus 64 plus 64, those three angles add up to 180 degrees. Therefore, y plus 128 is equal to 180. From there, I'm going to subtract 128. 128, subtract 128, and y is now equal to 52. So I know that this angle is 52, and I can use the fact that this line here adds up to 180 degrees to find, I need another variable. Let's call this variable z. I can say that angle z plus the angle that we just figured out, plus 52, those two angles add up to 180 degrees. And then from here, I can just simply subtract 52, and I can get z is equal to 128. From here, you might be wondering, was there a shortcut? And there is indeed a shortcut. If you were to look at this triangle with the exterior angle, this exterior angle z is the same thing as adding these two interior angles that are opposite of our exterior angle. 64 plus 64 adds up to 128. So there was a shortcut here. I did it the longer method, just because I think that's what most people will do. If this angle right here is 128 degrees, I will label that. This is equal to 128 degrees. And I'm trying to solve for this x. Because this is an isosceles triangle, this triangle right here, the base angles must be congruent. This x must also be this x. And all three of these angles, x plus 128, all must add up to 180 degrees. So I can simplify this and say that 2x plus 128 equal 180 degrees. From there, I can subtract 128, and I get 2x is equal to, what is that going to be, 52. And then from there, I divide by 2, and x is equal to 26 for our final answer, which we will then box. Technically, it is degrees, but it doesn't really matter. X is equal to 26. All right. And finally, our last problem on the practice test, number 19. We need to somehow figure out what x is, and we know that this angle right here, let's go ahead and label it just in case we forget. This angle is 7x plus 12, and that lives right here. All right, well, we have some information that this is 107. If this length is 107, then I can use the fact that there is a line right here to say that, we'll temporarily call this angle y, that 107 plus y add up to 180 degrees, because that defines a line. From here, I can subtract 107, and y is equal to 73. So I know that this is equal to 73. This triangle is an isosceles triangle. That's what these two tick marks mean. If I have an isosceles triangle, the base angles must also be congruent. Therefore, this measure of 73 is this measure of 73, and I can label this 73 as well. Finally, I can find this angle, which I will call z up here, by noting that 73 plus 73 adds up, or plus z, all three of these add up to 180 degrees. So I'll say that z plus 73 all add up to 180 degrees. So let's go ahead and simplify this all and say that z plus 146 equals 180. Let's go ahead and subtract 146, and we get z is equal to 34. So this is equal to 34 degrees. Because this angle is 34 degrees, by vertical angles, this angle over here is also congruent and equal to 34 degrees. Because we have a triangle right here that is isosceles with these two tick marks, these base angles must be congruent. Therefore, this angle over here is 34 degrees. That's 34 degrees, not 340. And because we know that these three angles add up to 180 degrees, I will temporarily call this angle W, I suppose. We'll say that this is angle W. Angle W and 34 add up to 180 degrees. Let's go ahead and say that. W plus 34 plus 34, that adds up to 180. Let's go ahead and combine our like terms. We'll say down here that this is W plus 68 is equal to 180. Let's subtract 68 on both sides, subtract 68 on both sides. So I'm going to get 112 is equal to W. Nice. So I can say W is equal to 112. And then from there, I know that this is a line. I can say that 112 is, if I add 112 and 7x plus 12, that adds up to 180 degrees. So let's go ahead and say that. If I have 112 and I add this 7x plus 12, that should all add up to 180 degrees. Combining like terms gives me 7x plus 124 is equal to 180. If I subtract 124 on both sides, subtract 124, I'm running out of room, so I'm going to go ahead and move all of this up. Thank you for technology. And that's going to be equal, 7x is equal to 56. And finally, I'm going to divide by 7, and x here is equal to 8, which is my final answer, and I will box. Again, let's make sure I was reading the question correct. It was indeed asking for the value of x, and I found the value of x to be 8 with a lot of work. That concludes the practice test for Geometry Unit 3. Let's go through each of these pages to see the answers. Thank you for watching.